It was almost unfortunate that he hit the clock like that with his presentation. Like there were, yeah, still some questions that we could have gone into.
Okay.
Yeah, we're just gonna give it another, I don't know, 1 minute, and then when there are enough people, we had enough time to come in. We'll start. Okay, yeah, let's just open the floor. Welcome to the second webinar. This time it's LINBIT SDS for Kubernetes, and we will go into, like usually with our developers, we will go into a demo, but also then into a presentation of the feature Amazon AWS. And we open the floor with Moritz, our Kubernetes integration developer, and with LINBIT since 2020. Afterwards, Gabor is taking over, and he's our main LINSTOR developer and with us since 2017. Please go ahead.
Thank you, Niels. So I'll quickly share my screen. And I hope you can see it right now. As Niels already told you, we're going to talk about LINBIT SDS for Kubernetes. And to give you a big overview again over what we're going to talk about, first of all, I want to talk a bit about LINBIT SDS on Kubernetes itself. What's it made up of? If you've watched the previous webinar, you will have seen a bit about LINSTOR. And then we'll launch into the demo of deploying our new improved operator and also demonstrate the backup feature for S3. And in the end, Gabor will talk about managing EBS volumes directly with LINSTOR. So the basics, basically LINBIT SDS is made up of several building blocks, and one of the most fundamental building blocks is just your normal Linux storage stack. So you have your Linux system, and then you have some disks, could be SSDs, NVMEs, hard drives, could be some virtual disk in a virtual machine. Bottom, typically on top of that, you have some kind of local volume management, like LVM or ZFS, which you can use to slice up your array of hard disks into smaller chunks or whatever you need. And then based on your requirements, you can have lots of extra features on top of that. You can have a cache, encryption, deduplication. So this is all basically included in the Linux storage stack. Another important component is DRBD, because you typically probably don't want your data to only live on one single server, because if that one server is gone, or I don't know, there's a power outage in one data center, then you can't access your data. And so you want data replicated probably across the network, maybe across different data centers. And this is where DRBD comes in, which is DRBD is distributed replicated block devices. And you can think of that as a kind of RAID 1 over the network. And you can have more than one mirror, and you can even have a node that doesn't even have local storage. So that's very flexible that way. And then basically the most important component, LINSTORE, which is the thing that ties it all together. You've maybe seen the webinar before. And with LINSTORE, you have a unified API for all these different storage components for DRVD. And you can basically request from LINSTORE, I want some volume placed on these nodes, and then the LINSTORE controller will talk to the LINSTORE satellites, which are the LINSTORE worker agents on each node, and create these volumes and set up DRVD replication and caches and whatever else you want to configure. And then what makes LINBIT SDS for Kubernetes a whole package is the LINSTORE operator, which is our unified way to deploy this whole stack on Kubernetes. And there are currently two different versions of that. There's the operator v1, which is currently the main and stable version, and the operator v2, which is currently in ongoing development, but should be stable enough really soon. And with the operator v1, you deploy it typically as a Helm chart. DRVD replication worked only on the host network, so you had to fiddle with the firewall on your Kubernetes cluster, perhaps. And it also built in some support for originally SQL databases as a LINSTORE backend, and then etcd, and then now the newest version of is using the Kubernetes API directly. And with the operator v2, we tried to streamline this whole process. So now you can use customize, which is already built in with your normal kubectl command, and reuse the container network. This is actually a really new feature of DRVD 9.2 that enables that. We basically can do the volume replication directly over the container network, and that means that you don't have to do any special firewall setups to get it to work. As a data store, right now we are mainly focusing on this Kubernetes data store because that's the one that everyone has available on Kubernetes. And one of the big improvements with the new operator v2 is we offer improved customization. Previously, if we didn't account for something in our Helm chart, then you were basically out of luck to get some specific feature to work or to add some specific customizations to the operator deployment. And now that is all working as expected. And yeah, so in the future, when we have a clean migration path from operator v1 to operator v2, then we'll finally deprecate operator v1 for those that are already using it. And with that, it's time for me to switch over to the demo. So I'll switch over to the terminal. And as is usual for my demonstrations, I have an empty Kubernetes cluster with 3 nodes running right here. And the first thing we will do, because we want to be good citizens, is to create a namespace for our LINBIT SDS. And then we'll create a pull secret, which is configured for our DRVD.io registry, where customers can download our container images. If you don't use that, there is also the open source Piraeus project, where you don't need a special pull secret to download that. But anyways, I'll create this pull secret. And now to actually deploy LINBIT SDS, we will use customize, which is this -k option. and then just reference our open source repository. And we don't want to deploy the config quite yet. We want to deploy step. And now Customize in the background will download this repository and create all the usual Kubernetes resources. And yeah, cloning this repository sometimes takes a bit of time, so we will have to wait for that. And now it timed out, great. Try it again. And if that doesn't work, I guess I'll have to fall back to a local copy of the repository, but I wanted to show that it works for everyone and not just on my machine. But maybe if it takes too long, I'll just use my local copy as you would if you used some kind of, okay, local CI. I guess that doesn't want to work. So instead of this, I'll use my local copy. And hopefully this one is quicker.
Yeah.
Okay, so now it finally worked. And we can check, it's already creating the operator pod, which might take some time, but this gives us time to also deploy the first configuration resources, which are just basically create a LINSTAR cluster and set up DRVD and everything on all available nodes. And we can check that this also worked, and you can see they are already almost started, which gives me time to talk about one feature of LINBIT SDS. We have a graphical user interface, which you can access via the browser. And I'll quickly demonstrate how to enable this on Kubernetes. For that, I have a special load balancer service, which I can enable. And let me quickly check that this IP address is still mine, and that's the case. So I can just create this load balancing service. And it's created, and this one will also need to give a bit of time to actually propagate through DNS, because right now it doesn't exist, but that gives us time to check in again with our pods. You can see most of them are running, some of them are still hanging in it, but the LINSTAR controller itself has already registered all these different nodes. And if you've watched the usual demonstration, you would, or my previous demonstrations of this, you would see that the IP addresses of the node itself were the host IP addresses, but right now these are the pod IP addresses. And so we are using the pod network here. And let's check in again if this works, and it does. So we can access the GUI right now and take a look at what that looks like here. And you can see the same information that would be available on the command line. You have the nodes. You have this, you have the node overview. We can actually take a closer look at one of those nodes. And there you have information about the different resource layers, the storage providers that would be supported, in which availability zone this, this node is running. And yeah, so that setup worked all fine. But if we take a look at the storage pools, we can see that we haven't configured any storage pools yet. So this is the next step. And this is something also changed in the operator version 2. With these LINSTOR satellite configuration objects, you can basically layer and or select a specific set of nodes and apply specific configuration only on those nodes. So right now, this satellite configuration says, I want to configure a storage pool on all nodes that have this label, so on every node in this zone, and it will create a storage pool of type LVM thin and is using this one host device. And let's deploy that and check back here. And you can see only one of our nodes is in that availability zone, and it has configured the storage pool with a size of 100 gigabytes. But actually, for my demonstration, I want to have the storage pool available on all nodes. So I'll just remove this selector, and now it selects all nodes for this configuration, and storage pool is available on all nodes. Yeah, so now we're almost ready to create our first volume. To create a volume, you need a storage class, and this can have many parameters, but there are sensible defaults for almost everything. So the only parameter I want to set here is this autoplace parameter, which basically tells LINSTOR, okay, for my volume, please create 3 replicas or mirror all the data on at least 3 nodes. And so we can also just apply, and then we can actually create our volume. And I've created this sample deployment, which has a start, it has a persistent volume claim, which is the Kubernetes way of requesting a volume, and it's using this storage class we just created and requests 500 megs of storage. And then I've just created a sample deployment which doesn't do anything, but it mounts the volume, and we can use that to explore the created volume. So let's create this deployment and take a look at the events, and we can see that provisioning has already succeeded on the LINSTOR side. If we take a look here at the available resources, we can see that it has created 3 resources on all the different nodes. And you can see that it's currently in use on this one node, and state is up to date. So that's as we would expect. So now I can hopefully jump into this container and take a look at this data volume I mounted, and you can see it's mounted, it's taken from a DRVD device, and it's around 500 megs and currently empty, but we can change that by writing something on the file system. And I'll use yes here to quickly fill up the file. Should be good enough right now. It's already full, all the 500 megs written with repeated messages on which pod we are currently running. And yeah, so volumes work as you would expect. And now I want to show you some interesting use cases for backups to S3 for disaster recovery. So first of all, for disaster recovery, you want snapshots, but these snapshots you probably don't want on your locally on your cluster, because if your cluster is gone, and this is something that in the age of cloud computing may happen easier than it was previously, because you don't have to physically remove any servers, you just have to write the wrong command, perhaps. We want to create snapshots and ship these snapshots to some offsite location. And in our example, this will be Amazon S3. And snapshots work basically the same in Kubernetes as volumes work in Kubernetes. So you have a snapshot class, which is like the storage class. And here we set a lot of different parameters. We request that it's a S3 snapshot. We can specify the bucket and endpoint and so on. Perhaps you don't have any, or if you're not running in the Amazon cloud, you don't have S3, but you have some compatible endpoints or some compatible product, then you can use that, of course, as well. And then lastly, we want to secure access to this bucket, of course, because it's holding our private data. So we need some kind of access control. And this is using normal Kubernetes secrets, where we specify access key and secret key for this S3 bucket. And this I first need to create. And then I'll also need to create a passphrase in LINSTOR. This is something that's still missing from operator version 2. Operator version 1 automatically creates a passphrase for you. This one doesn't currently, but it will be added soon. So let's create an encryption. This is not spelled correctly, controller. So let's create a passphrase. Well, this one is a new error.
You want to create it, not enter it.
Oh, sorry. Thanks, Gabor. So, and now I've misspelled it. I'll probably need to do it again. So now it worked. And okay, we have created the secret, we have entered the passphrase, and that means we can create our snapshot. One thing I didn't show yet is the snapshot itself, which just references the snapshot class and the persistent volume we want to create a snapshot or backup of. So let's do that. And let's check on the status here. You can see it was created, but it's not yet ready to use because LINSTOR is still uploading the data to S3. And now it's ready to use. So it has uploaded the volume content to S3, and we can quickly check that it actually did something. We check the bucket here. So you can see there's some metadata file here, and then the actual volume contents. And because I've written the same passphrase in the volume a number of times, it compresses very well. So now let's say we have some kind of disaster, we accidentally delete all our cluster resources. So I'll just delete the deployment and delete also the snapshot. And so if we check Kubernetes, there's no volume snapshot content. If we check on the LINSTOR side, then we will see that there is also no snapshot anymore. There is no resource anymore, so everything is gone basically, except we still have our backup configured. And this is showing still showing this snapshot from before, from S3. And we can restore from just that. If we take a look at the restore procedure, we again have to specify a new volume snapshot, but this time we don't reference persistent volume claim, but we reference this volume snapshot content, which we also have to create, which is here. And in here, you reference this value from the backup, and I just need to change that now, because otherwise this won't work. So let's replace this with that, and then I can, and just quick to show you, then we create this persistent volume claim referencing the snapshot created before, and then I've just created a second copy of this deployment. So let's apply that. And if we take a look now at the volume snapshot, you can see that it's currently marked ready to use. If you take a look at the persistent volume claims, it's still creating because it's downloading the volume. In LINSTOR, you can see it's currently restoring, but this shouldn't take too long because the snapshot is quite small. Now it's successful, and now the persistent volume claim we created also quite soon. Now it's created again. And we can probably already check back in on our deployment and the volume. And we can check that the content of the file is still there. And that's the file as we would have expected it. And yeah, so this is how you can use S3 as disaster recovery. And with that, I'm done with the demonstration, and I think Gabor has something prepared for us.
I do, after I found the unmute button at least. All right, let me share my screen. Okay, so until now, Moritz was talking about how to use LINSTOR in Kubernetes. What I will show you now is completely without Kubernetes, so LINSTOR only. We do have some plans to add this functionality into the operator at one point, but we are not done with that yet. So for now, it's just LINSTOR only. All right, so EBS, in case you don't know, we are talking about the Amazon Elastic Block Storage option to provide volumes for you. And you can access those storages from the EC2 instances hosted by Amazon. And this demonstration is about how to set up LINSTOR so that you can let LINSTOR create for you EBS volumes, and let LINSTOR connect the EC2 instances to use those EBS volumes. So just as Moritz, I'm also starting with a completely empty LINSTOR cluster right now. So all we have at the beginning is the controller. And also we need to set up the creation, the encryption in order to securely store some passphrases in the database. The next step is to create some EBS remote objects. We simply call them, this EU Central 1A part is the availability zone within the Amazon cloud. So we need to define two different remotes because we want to address two different availability zones. We can name those remotes as whatever we want, but they have to differ. Obviously, the access key is required as well as the secret key, but if you omit this, you will be prompted for it. Next, there is a very unique command, or one of the rarer commands in LINSTOR, that we do not create a normal satellite, what we call them, but we create a special satellite. The thing that's special about them is that not just that the first parameter here is the node name, but the second one is the remote we previously created. The special thing about these kind of satellites is that they are actually running the same virtual machine as the controller running. So it's not a different virtual machine, it's the controller spawns new Java processes, literally. This create AWS target command also creates automatically one single storage pool and links that storage pool to the corresponding availability zone, which you just defined in the command. Next, we need some usual steps, create a new resource group and a volume group, and spawning such a new resource. LINSTOR would like to create new resources in these, EBS target storage pools, but these LINSTOR special satellites do not have local storage because it's running in the VM of the controller, where LINSTOR does not assume to have any storage. So what they do in the background is to send Amazon requests to create EBS volumes for this. So this is how we get our EBS volumes deployed. So that was the first part. The second part is how do we access those just created EBS volumes? So as I mentioned before, you will need EC2 instances. You have to make sure that they're in the same availability zone, because an EC2 instance can only access or attach a disk to itself from the same availability zone. But in this setup, we already have two EC2 instances. And now we are creating normal, so-called normal satellites within those two instances. And what we are doing now is we prepare DLBD to use internal IP addresses, not the external IP addresses, because if both of them are running in the Amazon cloud, I highly assume that they have a better network than going through the internet. So we just set the preferred network interface property on both of the nodes. And we also just create a new EBS init typed storage pool. Again, we have to specify to which availability zone it belongs. And the last statement is basically very same as usual, just create a resource in the two satellites. Tell LINSTOR that these are supposed to be EBS initiators. You will get those so LINSTOR will send Amazon an attach request so that these EBS volumes get attached to the corresponding EC2 satellites. And since we specify the usual layer setup, LINSTOR will also configure DLBD above these two. So it's fairly simple. We tried to make the commands just like every other command, with the exception of a few special commands in the very beginning, but this should be everything you need for this setup. That's basically also it from my part. Short and compact. Are there any questions?
Yeah, let's give it a minute. Okay, and Andre is watching and has some questions for us. I start with the shorter one. What are the pros and cons of managing EBS via LINSTOR while Kubernetes has the native CSI driver? Maybe short in question, but long in answer.
Gabor, should I jump in?
Yeah, please.
So to my knowledge, the native EBS volumes don't have an option to be online replicated between different availability zones. And this is exactly what you get with what Gabo just demonstrated. You have EBS volumes and not in a single AC, but in multiple online replicated. I would say that's the pro. What's the con? I'm not aware of one.
Okay, we go on the next question then. So you said that operator V2, oh wait 1 second, there's another one. Okay, I go with that one. You mentioned that operator V2 now will use the pod networking. Will DRBD use the pod networking for application as well? Are you going to support, shall we go with that first, maybe?
Yeah, I can answer them one by one. So
Yeah,
yes, DRBD is using the pod network as well. And the next question was, what was it? Are you going to support Multus, I suppose, to separate main pod network from separated data network? Excellent question. This is something I plan to look into. It shouldn't be too hard to support, and I plan on doing that. Yeah, but first I need to iron out all these other smaller issues that are still plaguing version 2 until we have basically feature parity, and then I can work on new features. And then is there a migration from version 1 to from version 1 to version 2 planned? Yes, we have that planned. Of course, also depends on when we say version 2 is stable for everybody, and then we will work on the migration path for that. And eventually version 1 will be deprecated and no longer supported.
And then there's one more. Are the other cloud providers going to be supported by LINSTOR, e.g. Google Cloud, Azure, OpenStack, and so on?
And I take that one as well. So yes, they are definitely on our list. They will coming. So the bigger cloud providers and maybe some other cloud providers from Europe, so that we can address customers who want to have all the data hosted in Europe, for example.
Okay, and there one more question came in about EBS. Can resource groups be used to spawn EBS resources?
Yes, at the very beginning, I used actually the resource group spawn command to spawn the EBS target, so the actual EBS volumes on the Amazon side. The resource create command in the end was used to create the EBS initiator, so the diskless version of those. The reason why this later version right now requires this resource create command and not the resource group spawn command is that the resource group spawn is not designed to allocate diskless resources, because LINSTOR simply does not have a meaningful metric about where to deploy those, and everything that is diskless right now is a little bit complicated to use the spawn command for. That's why the EBS initiators were created manually.
Okay, one more question is here, also from Andre. Didn't you think on some pluggable interface to let people develop out tree plugins for LINSTOR by their own? Who wants to go with that?
I'm not fully sure in what regard pluggable interface.
let me jump in here.
Sure.
So right now, all the drivers for block storage, they are built in into LINSTOR, right? So they have to be checked into our code base and compiled with LINSTOR itself. And yeah, so would it be possible to enable that there are external backend drivers and that they are dynamically loaded in Java? I don't know. Cover.
In theory, yes, we could do something like that. The problem is that every provider, how we call them internally right now, requires in the details a few different things, and those are quite hard to just let the plugin do whatever they want, because we would need to give the entire LINSTOR cluster state to the plugin, which the satellite doesn't have in many cases. So it's not that easy. I mean, we do have some interfaces internally, so if you want to write actual just new implementations of those providers and get a pull requests, this is actually working right now. If we want to make it pluggable, I'm not sure if that's really worth the developing.
Yeah, so maybe at this point we should stress LINSTOR is open source, and we are pretty open to accept driver contributions.
No, I just saw that the way Kubernetes is first it was also implementing in-tree plugins, and now they're trying to get rid of them. They have just one, CSI, the pluggable interface, and they moved all the implementation outside of the Kubernetes. I just worry, or I just thinking that in a while we can have so many drivers and implementations in LINSTOR itself, so it might be difficult to support all of them. And it might be a good idea to move it outside of the LINSTOR itself. How it can be done, actually, I don't know. I think it might be good to have some binary, for example, the same way like Kubernetes is doing that. You can develop CSI driver and implement some external calls to it. Actually, I don't know. That's just an idea. I think it's a good idea, a good thing to think about.
Yeah,
I mean,
yes, I follow your thinking, Andre, and maybe it's just a year or two too early to be at that stage, and maybe we come to exactly the stage where Kubernetes already was, right? That we need to move the drivers out.
Thank you a lot for the presentation.
Yeah, thank you too for yours. Okay, any more comments? Otherwise, we would conclude here and start with the next one at top of the hour, so in 15 minutes.
Good. A short break.
Yes. All right. So see you at the top of the hour. Bye.
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 Bye.